This section just kind of covers some basic compaction inspection questions. Generally, a number of different soil types may be encountered on projects. Each soil type may require different handling and or compaction techniques. The compaction inspector / tester must be alert to changes from one type of soil to another. The optimum density and moisture content used may be well change the additional lab work to be required in the field. So every lift must be compacted to the required density before the next lift is placed on there. And should be enough tests taken to ensure a passing uniform grade. The tests will be taken at various locations on the field to ensure uniformity. So on our dirt lifts, our 12-inch loose lift of soil, aggregate is compacted in 6-inch lifts and then compaction tests taken every 12 inches. Principal duty is to take compaction and moisture tests to compare results to the proctor, determine the location and offset of compaction tests, keep the engineer or grade inspector always informed of test results, and alert to changes in soil. Become familiar with the project plans and specification, have good lines of communication, safety, and keep organized records. You may be required to conduct additional tests than what's required if you encounter unsatisfactory conditions such as spongy surface, equipment working unusually hard to achieve compaction, or appreciable changes in color and textures of the soil. So failing compaction tests, if tests are noticeably short of specifications, you should perform a recheck just to see if you read the volumeter wrong or wrote down a wrong number, and inspect the equipment for leaks or damage. If the check tests are close to the required density and optimal moisture, and you're sure your equipment procedures are good, the visual observation of the material leads you to believe the maximum dry density and optimal moisture should have been obtained, then perform a 1 point. So if you're got unusually hard material and you're still not passing the compaction test, you probably are using the wrong proctor, and the contractor will be sure to ask you if you're sure you're right. If the grade is that hard and you're still getting failing tests, he may even ask you to run another proctor. So do not permit any lifts to be placed over failing lifts. Frequent compaction tests should be performed at the beginning of the project this kind of will force the contractor to develop and maintain a uniform operation throughout the project. Locations of the test sites are critical. If the test results conform at these locations, the rest of the earthwork is assumed to conform as well. To determine the test locations, use the table of random numbers. The random number has no pattern or sequence of how they occur. And an alternative method for determining a random number is the use of a scientific calculator or Google random numbers, or however you want to do it. As long as you can document how you come up with your random numbers is acceptable. As an inspector, you should let the contractor know that the random numbers will help schedule locations of tests ahead of time, but the contractor should not know where the tests are being located. To locate a test site, you'll need a longitudinal coordinate and a latitude coordinate. Longitudinal coordinate is the distance from the end to where the test site is taken. The lateral is the distance from the edge, the outside in. Here's just a snapshot of a section of the random numbers. And this table is found in your sampling testing manuals. First, determine the length and width of the test area. Point to the block numbers on your random sample. So you just kind of close your eyes, circle, drop your pen. That's the block that you would use. The first line of numbers would be used for your length, and second line of numbers would be used for your multiplier for the width. We have 2 test sites needed for a test area of 1,000 foot by 40 foot. So a block of numbers was randomly selected. And for example, here, so the first row of numbers would be used for our length, so a 0.39 and a 0.29. And then the next slide is our 0.42 and 0.82 for our widths. So test 1, 1,000 foot, at 0.39 is 390 feet from the beginning of the test location to our test site. Test 2 at 1,000 foot, 0.29 is 290 feet. And then for our width of a 40-foot area of 40 times the 0.72 comes out to 17 foot rounded. And for test 2 is 33 feet rounded. So you go to the next slide, it shows you. So test 1 is 390 feet from the beginning, 17 feet in. Test 2 is 290 feet and 33 feet down to determine your location. And that's pretty much in there. Just some other general stuff is on a widening type project. Each side of the road is considered its own sublot. And if you're building a new grade, the whole width by your lengths is one lot. So